Salesforce provides several powerful features that can be enabled directly at the object level using simple checkbox settings. These options enhances reporting, collaboration, automation, and integration. During our object creation session, we looked at these checkboxes in brief, but in today's session, we will get into more details of these options. The first thing that we are going to discuss is about allow reports. Allow reports enables the objects to be included in standard and custom report types. For example, enabling this on the custom object like job application allows HR to build reports on application status, submission date, etc. When you check the allow reports option on a custom object, Salesforce auto generates report types based on how that object is related to others through master detail and lookup relationship. If your custom object has a master detail relationship with another object, say for example, in our scenario, job application has a master detail relationship with candidate object. Enabling allow reports will automatically create two report types. The two report types that are created are candidate with job application, where candidate is a master object. It shows all candidate records with related job applications. It also creates a report type with detail as the primary object. So the report type is called job applications, which displays job application records and includes fields from the master, which is candidate object. The report type is created regardless of whether the detail object is displayed as a related list. In our previous sessions, we created a job application object with two master detail relationships, one with position object and the other one with candidate object. Because a custom object, job application, has two master detail relationships, Salesforce automatically generates four standard report types to help us analyze the data. A report type in Salesforce defines the primary object for your report and the related objects whose fields can be added. Each report type determines which records are included, which fields you can display in the report. Report types acts as a template or structure for building reports. Let us now navigate to reports. To navigate to reports, click on new report. In the category, I am selecting all. And if you observe, there are a lot of report types which are categorized as standard because Salesforce has a lot of standard objects with a lot of relationships predefined. So if you observe, there are some report types that are created because of enable report setting on my job application object or positions with job applications and candidates with job application and positions. So these are the four standard report types that Salesforce generates because of the enable report setting on our object. Now let us see one of these report types. I'm just selecting the position with job application and candidates and clicking on start report. Observe the label. Here, position indicates the primary object. You can also include fields from job application and candidates. The primary object determines which records the report is based on. Fields from related objects can be added, but the base is always the primary object. In this session, we are just exploring how report types are generated. In the future sessions, we'll go deeper into building custom reports using these types, applying filters, grouping data, and adding charts. For lookup relationships, Salesforce still creates a report type for the object itself when allow reports is enabled, but does not automatically create combined report types like in master detail unless you manually define them. If interview has a lookup relationship to position, enabling allow reports on interview creates a report type called interviews. You won't get position with interviews or interviews with position unless you define a custom report type manually. Lookup fields can be added as columns in reports. Use custom report types if you need to build cross-object reporting logic for lookup relationship. Let us say you have position, which is a master object, job application, which is a detail object, and interview, which is a lookup to position object. With allow reports enabled, you will get job application with positions with job applications, and interviews, but not positions with interviews. The second setting that we are going to talk about is allow activities. Allow activity allows users to create and relate tasks and events to records of this object. Enabling on position lets recruiters log follow-up calls or schedule interviews directly from the record. The allow activities setting enables an object to support Salesforce activity management features like tasks, events, emails, and activity timeline. Behind the scenes, when you check the allow activities on an object, Salesforce automatically enables two related lists: open activities, which shows pending tasks and events, and activity history, which shows completed tasks, events, and logged calls or emails. The object becomes available in the activity timeline in Lightning Experience. Users can view and log calls, send emails, create tasks, and schedule events directly on the record's timeline. You can relate tasks and events to this object via the what ID field. The what ID field on activities links the task or event to any object with allow activities enabled. You can use activity quick actions on the object. Quick actions like log a call, new task, new event become available in the user interface. You can report on activities linked to this object. In reports, tasks and events can be filtered by the related object. Let us say you enable allow activities on a custom object position. Recruiters can log calls made to candidates about a position, schedule interviews or events directly from the position record, view a timeline of all communications and follow-ups for that role. You cannot enable this checkbox on some standard objects where it is restricted. For example, opportunity line item. Disabling the checkbox removes the activity related list from the page layout, but it does not delete the existing activities. The existing activities will still be in the database. Enabling allow activities makes an object action ready, letting users manage follow-ups, meetings, and calls, all in context. It enhances productivity and provides a 360-degree view of engagement history. Earlier, when we created the position object, we enabled allow reports. As a result, Salesforce automatically establishes relationship between the position object and the activity objects, tasks, and events. If you observe, there is a field called related to on event object, which has lookup relationship to position object. Similarly, when you go to task object, so in the related to, you'll find the lookups for these objects because I enabled allow activities on these particular objects. Now let us go and open an existing position record. If you observe, there is a related section in the record which has two related lists, open activities and activity histories. Open activities shows all the activities that are still active, and activity history shows all the historical activities. These related lists are added automatically to the particular object. There is an activity timeline on the right side of your Lightning page. The timeline displays past and upcoming activities in chronological order. It makes it easier to track the sequence of interactions. Both related lists and timeline component provide helpful buttons or actions to quickly log the interactions. These buttons typically are log a call, send an email, event, new task, etc. Wherever activity tracking is needed, like in recruitment, sales, or service, Salesforce provides powerful tools to manage interactions. We will explore how these activities can also be reported and automated in upcoming sessions. The third setting that we are going to talk about is track field history, which tracks changes to specified fields, storing who changed what and when. For example, enabling on candidate to track changes in application status or expected salary, which is useful for audits and process transparency. The only 20 fields can be tracked per object. The track field history setting allows Salesforce to automatically capture who changed what and when on specific fields of an object. It is primarily used for auditability, compliance, and debugging. Behind the scenes, when you enable track field history on an object and select specific fields, Salesforce creates a dedicated history object. For standard objects, this is predefined object. For example, for account, it creates an account history. For opportunity, it creates opportunity field history. For case, it creates a case history object. For custom object, Salesforce create a new custom object with suffix _history. For example, when you enable track field history on position object, Salesforce creates position __ history for this object, which stores the historical change records for each tracked field. You can only track 20 fields by default on any object. Every time a tracked field changes, Salesforce logs old value, new value, user who made the change, date and time of the change, and the actual field name which got changed. This log entry is saved as a new record in the associated history object. The object's page layout gets a field history related list. This shows a timeline of all tracked field changes per that record. Users can view a change history inline without accessing setup. API access is enabled for the history data. You can query historical changes using SOCL. Salesforce retains field history data for 18 months in org and up to 24 months via API, unless you use Field Audit Trail, which is a paid add-on. You can track up to 20 fields per object for standard Salesforce license. 60 fields per object if you use field audit trail. Formula fields cannot be tracked. Changes from workflows, flows, imports, and apex are all logged, not just UI edits. Now let me demonstrate how field history tracking works using the position object. I am in the position object. I went to the fields and relationship section, then click on set history tracking. Since I have already enabled field history tracking on this object, the screen displays all the eligible fields that can be tracked. Remember, formula fields cannot be tracked as they are calculated, so they are not part of this list. Now in this object, I am tracking min pay, max pay, hiring manager, and open date fields, and I am clicking on save, and I'll open one position record. Now let me go and modify these values and see how it is impacted. When your field history tracking is enabled, Salesforce creates an object called position history. So this history object is created by default. And when I go and make any change in the fields that I tracked, so for example, I'm modifying the min pay to 100,000 and max pay to 150,000. And I'm also adding hiring manager as Trailblazer Tutor. Then I'm clicking on save. I made changes to 3 different fields. So when you go back to the related list, you will see 3 different entries for all these 3 changes. It tracks the date when the change was made, who made the change, and which field was modified, and what was the original value, and what is the new value. And one more thing that you need to observe here is you can track old and new values for all the other fields, but for a pick list and rich text or text area fields, you can only track changes. The fourth option that we are going to talk about is allow in chatter feed, which lets object to participate in chatter. Users can follow records and get updates in their feed. The allow in chatter feed setting enables an object to participate in chatter collaboration, allowing users to follow records, post updates, and receive automatic feed updates when important changes happen. Behind the scenes, when you check allow in chatter feed on a standard or custom object, the object becomes feed enabled. A chatter feed is added to the record page. Users can post comments, tag colleagues, share files, and collaborate directly from the record. Salesforce automatically posts updates in the chatter feed when tracked fields on an object change. The feed shows a changed field summary for visibility. If status field is tracked field on the case and it changes from open to in progress, the chatter feed posts an automated update. Users can also follow a record, meaning users will receive feed updates when tracked changes occur, fostering collaboration across teams. Developers can use components like Force Chatter Feed or Lightning Record Feed to display feeds in custom user interfaces. Feed data is also available via SOQL query. For that, you need to query objects like feed item and feed comment, etc. Let us see you enable allow in chatter feed on the custom object project. Team members can post project updates directly on the record. Everyone following the record gets notified when key fields like status or start date change. Managers can tag users and collaborate on delays or risks all in real time. Enabling allow in chatter feed makes the object collaboration friendly, allowing users to share insights and updates right from the record, improving team performance, teamwork, and transparency. Let me demonstrate how to enable chatter feed. I am in the position object and I'm going to the details section, clicking on edit. I have already enabled allow in chatter groups for this object. So I'm clicking on save. I also made a change to my layout and added a chatter tab. And now if you observe, all the updates that happen to this object are documented here. So for example, if I make a change from max pay from 150,000 to 150,001, the feed will be updated here. You can mention people, start collaborating with the people directly on the record. So whenever any user follows this record, for example, Trailblazer Tutor has followed this record. Whenever any changes happen on this record or whenever someone collaborates on the record, this user who is following will get a notification. Let us discuss some other settings that object creation page provides. The allow bulk API access setting allows an object to be accessed via Salesforce bulk API, which is used for high volume data operations such as mass inserts, updates, deletes, or upserts, especially during data migration or system integration. Behind the scenes, when you enable allow bulk API access on an object, the object becomes available to bulk API jobs from tools like Data Loader, Workbench, Jitterbit, MuleSoft, or custom integrations using the bulk API V1 or V2. The object is listed in metadata for bulk operations. It appears in the objects list when using tools considered for bulk API mode. Records are processed in chunks, and each batch is processed independently by Salesforce. Let us say you have a custom object invoice storing large amounts of financial data. By enabling bulk API access, you allow your finance integration to upload 50,000 invoice records nightly using a batch integration via MuleSoft. Without this setting enabled, the integration would fail or be forced to use sufficient REST API. The setting must be enabled to use the object with the bulk API, even if the user has permission. Security and sharing rules still apply, so the API will only access records the integration user has access to. Enabling this does not impact performance negatively, but you should still monitor the usage of async Apex jobs, API limits, and concurrent patches. The common tools that use bulk API are Salesforce Data Loader, using the checkbox on the data loader settings called Use Bulk API, Workbench for large CSV uploads, ETL tools, for example, Informatica, Delboomi, Jitterbit, MuleSoft, etc. Custom Apex integrations calling job info, batch info, etc. Enable allow bulk API access for objects that need to support large volume operations via integrations or admin tools. It is essential for scalable data management, but must be paired with good governance and monitoring. The next setting that we are going to discuss is Allow Streaming API Access. The Allow Streaming API Access checkbox allows a standard or custom object to emit change notifications over the streaming API. This is key for building real-time integrations and event-driven architecture. Behind the scenes, when you enable Allow Streaming API access on an object, the object is included in change data capture and push topic subscriptions. The external systems can subscribe to these changes using CommentD or tools like MuleSoft, Heroku, triggers, or external apps to listen for real-time changes. A system object like invoice change event is created automatically. This object carries lightweight read-only change measures. Imagine you are syncing Salesforce order records with an ERP system. With Allow Streaming API access enabled on order, anytime an order is created or updated, a change event is emitted. Your middleware listens to these events and syncs the data in near real time without polling Salesforce. This setting works with both standard and custom objects. It can be used in platform events, Apex triggers, and external event listeners. All changes respect sharing rules. Only visible data is published to subscribers. You can control what fields are tracked in CDC via setup, change data capture. Events are retained for 3 days, like 72 hours, and can be replayed using replay IDs. Allow Streaming API access is essential for building real-time, event-driven systems that need to respond immediately to Salesforce data changes without relying on expensive or inefficient polling mechanisms. The next setting that we are going to talk about is Allow Sharing, which allows manual and criteria-based sharing on records for a custom object. It activates Salesforce record level sharing model for that object, giving admins and developers more control over who can see what. Behind the scenes, when you check Allow Sharing on a custom object, Salesforce enables the sharing infrastructure for the object. A sharing table is created in the background. For example, if you enable it on position object, a position underscore share object will be created. This table stores record level access entries for users, roles, groups, and territories. The object becomes eligible for manual sharing by users when object OWD is private or read-only. Apex-based sharing via share objects in code. Criteria-based sharing rules are set in setup. Owner-based sharing rules for record owner visibility extension, and territory-based sharing if applicable. Let us say you have a custom object project. With Allow Sharing enabled, you can set the organization-wide default to private. You can then create a sharing rule that shares any project record where region equal to APAC with users in the APAC sales role. You can also write Apex code to manually share specific records with selected users. This setting is only available for custom objects, not standard objects. You must enable this checkbox before deploying Apex's sharing code or creating sharing rules. The object's OWD must be private or read-only for sharing rules to take effect. You cannot retroactively enable sharing rules if the setting is unchecked and Apex code using the share object already exists. The last setting that we are going to discuss is enable licensing. This setting is primarily used by independent software vendors who distribute managed packages via Salesforce App Exchange. This setting allows developers to control access to a custom object based on whether the user has a valid license for the package. Behind the scenes, when you check enable licensing on a custom object, if available, the object is tied to the package license. Only users with a valid active license for the managed package can access records on that object, and unlicensed users will be restricted. ISCs can ensure their app features are not used beyond the agreed number of licenses. This is enforced automatically by the platform. This setting is only available for managed packages created using Salesforce ISV partner program. Licensing is controlled using the license management app provided by Salesforce. This does not replace permission sets. Users still need object and field level access through profiles and permission sets. Salesforce will automatically block access to the object if the user's package license is expired or removed. Enable licensing is a must-use setting for packaged apps that needs license-based access control to custom objects. It is a security and monetization feature that helps ISPs enforce usage rights across customers. All these 8 checkboxes expose powerful features with a single click, but should be enabled thoughtfully based on the object's role in reporting, automation, security, and integration. We will be covering the remaining advanced settings that are presented in this last slide in our upcoming sessions. Allow bulk API will be discussed during our data management session, where we explore large volume data operations. Allow streaming API access will be covered in the API integration session. While learning about real-time event notifications, allow sharing, we will dive deeper into this setting in our security and access control session, where we cover record level sharing models. The setting enable licensing is not within the scope of our current training series and will not be covered.